Good morning.
Good
Yeah, hi
morning.
everyone. Yeah,
Hello,
guys, can
good
you all hear
morning.
me?
Good morning, Govin.
Hi, good
Yeah,
Good morning.
Yeah,
morning. Yes, yes.
very good morning. Guys, my voice is clear.
yes.
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 Documentation and supplementary material.
Okay, yeah, Manvir, we'll do one thing. In the weekdays, we can connect, okay? And we'll discuss on this, okay?
Sure. Thanks, Govind.
Perfect. So guys, I'm sharing the screen. Guys, is the screen visible? Everyone?
Yes.
You all can see them? Okay.
Yes,
Yeah.
I can see. Yes.
So guys, in the last class, we were discussing machine learning topic, right? And we learned about the linear regression machine learning algorithm. And logistic regression. You have seen this machine learning algorithm was used to solve regression type of problem. And it was used to solve classification type of problem. But today we will be learning one machine learning algorithm that is called as KNN, K nearest neighbor, K nearest neighbor. Actually, this machine learning algorithm can solve both regression and classification type of problem. Okay, it can solve both this stuff. And today we'll also be learning how to load data from sklearn library. Because when you go for the interview, your interviewer may ask you to load data from sklearn library. They will not provide you any Excel file or CSV file. Okay, so you have to use a built-in data set. So it's very important to understand how you can use them. Perfect. So these two things we will be discussing today.
Yeah. And Govind, since how to upload the data, um, I think in real life, if I want to load my data, will I be using first to upload on sklearn? And I think I'll ask that question when the class
If you
during that
want
time.
to, see, if you have your own data set, there are two options. Either you upload your data first in a database, correct?
Mm-hmm.
And from that database, you load in your Google Colab. First approach. Second
Mm-hmm.
approach, you can create an Excel file or CSV file of your
Mm-hmm.
data set and load in Google Colab. Usually what we were doing previously.
Got it.
But
Okay.
you cannot load in sklearn by yourself.
Got it. Okay. That's sklearn is just for, they already have some data sets where we can pull the
Yes,
information from.
yes,
Oh, got
yes,
it.
yes.
Okay.
Why let me put the heading here. K nearest neighbor. It stands for K nearest neighbor. It is a supervised machine learning algorithm used to solve both regression and classification type of problem. Used to solve both regression and classification type of problem. Second point, next point is it is a non-parametric. It is a non-parametric machine learning algorithm. What is the meaning of non-parametric? Non-parametric means it does not have any function. Any function. See, in linear regression, you have seen one function was there. Y equal to beta naught plus beta 1 plus x1 plus beta 2 x2. These kind of equation were there in linear regression. In logistic, you had 1 upon 1 plus e to power minus y, sigmoid function, right? But in k nearest neighbor, we don't have any such formulas. Therefore, it's called as non-parametric machine learning algorithm. Now, having said that, it can solve both regression and classification type of problem. So it will have two categories. Okay. So first we'll discuss how KNN can be used to solve a classification type of problem. Let me just write here first one more point. Note. In KNN, we have to assume a value of k in the beginning. We have to assume the value of k in the very beginning. So mostly we take k equal to 3 or k equal to 5. Okay, these are the best values. By multiple testing, they have found either you can pass k equal to 3 or k equal to 5. What will be the answer if you pass 3 or 5? What is their significance? Now you will be learning about it. So heading will be case of classification, means how KNN will be used to solve classification type of problem. So step number 1, I will first write few steps here. First, it will assume one value of k. Say k equal to 5. Okay. This is the value of k you have assumed. Step number 2. In case of classification, it will have classes. Say 2 class. Okay, let's say you have 2 classes. I will also plot the image. Let me first write all these steps. Step number 3. It will try what it means this machine learning algorithm. This machine learning algorithm tries to compute the 5 nearest distance points. Okay. And step number 4, the class which have maximum point in that class only new point will assigned. Okay, I will explain you these steps with the help of example. So guys, there is something called as Euclidean formula. Euclidean distance. Go on mute, everyone. Listen, what is the use of this Euclidean distance formula? So this particular formula is used to compute the distance between two given points. this formula is used to compute the distance between two given points. Let's say, guys, in a two-dimensional coordinate system, we have 2 points given. This is your y-axis and this is our x-axis. I have 2 points, point A and point B. So the coordinate point of point A is x1, comma y1. This is what? x2, comma y2. So distance between, I want to compute what is distance between point A to point B. So it is nothing but distance from point A to point B under root of x2 minus x1 square, y2 minus y1 square. Okay, so when you compute this equation, you will able to find the distance between these 2 points. Everyone understood the formula? What this formula is used for? Clear?
Yes.
Yes.
Okay.
Yeah.
Now come back to the case. So I will plot one figure here. X, Y. Let's say, guys, we have 2 classes. Okay. So the first class is this. So there are some points which are categorized in 2 classes. Now, let's say this is your class A. This is class B. You got a new point here. Now, in case of classification problem, your task is to assign the new point in class A either or class B. This is what you have to do. So step number 1. First, it will assume one point, okay? One point of K, one value of K, one value of K. So what I have assumed? K value as 5. So here, K value is assumed as 5. It means I will be selecting 5 nearest point. See, this is your new point. So which nearest 5 point can be allocated here? How can you compute the nearest point from this new point to these points? Which formula will be helping you to compute that? Euclidean distance formula. So with the help of Euclidean distance formula, it will compute the distance of all the points, okay, with respect to this new point. And then it will find that what are the 5 nearest point we have, because when it will compute all the distances, then arrange in the ascending order, and it's very clear that you can able to find the first 5 points which are nearer to this new data point. Okay, so let's say this is point number 1, 2, 3, 4, 5. These are the 5 nearest data points, okay, from this new data point. Okay,
Govind,
so
why?
in case
Hey, Govind, I have question means I know this is just for an example, but why are you picking the nearest point starting from this red cross? It could have been like from the white cross also, like
from the
three, the yellow one means is that you are just presenting is just an example means I'm
yes,
saying
yes, just an
yeah.
example I'm presenting.
So it could be from the yellow side also, yellow cross, and
Yes,
then
yes,
red
yes.
cross.
It can be from that side also, because
Correct.
anywhere I have to pick. Yes.
Okay. Understood. Okay. Thank you.
Okay. So let's, because I don't know which point is near, I'm just assuming it. So let's say, guys, it has taken these 5 points as the nearest data point from this new point. And what formula used behind the scene? Euclidean distance formula. So in case of classification, it will have two classes. Okay. It will have classes. How many classes I am assuming here? Two classes. Yes. So in my figure also I have two class. Red points is class A and yellow point is class B. Third point. This machine learning algorithm tries to compute the 5 nearest distance point, because you have taken the value of k as 5. So it will compute 5 nearest data points from this new data point. The class which have maximum points, in that class only the new point will be assigned. So if you see guys, step number 5. Your class A has how many points? 3.
3.
And your class 2 have, class B have 2 data points. So according to majority voting, this algorithm is there in your KNN itself. Okay, automatically this will be applied. According to majority voting technique, the new point will be assigned to which class?
A.
Class A.
Majority.
This is the case of class A. This is how every new point will going to be classified in either of the class. There can be 5 class also, 6 class also. That will be on a multi-dimensional plane. I have taken 2 class just to explain you better in 2D space. Everyone understood? Because you don't have any formula here, first of all. Based upon that formula, it will work. No, because that's a non-parametric machine learning algorithm. It is distance based. And which distance I will be using? Euclidean distance formula. Okay, everyone. 50% is clear? 60%?
I have a question. So you said in 2 classes it's easier to pick the majority, but if it's like let's say 5 classes, then it's 1 point each. Then how it will choose the majority vote?
So definitely, let's say you have 4 classes. Class A, class B, class C, class D. So in that case, I somehow I need to increase the value of k, right? Because or if you're let's say taking 5k value, 1, 1, 1, 2. Let's say we got selected D. 1, 0, 0, 3. This can be the case, right?
4, yeah.
5, 0, 0, 0. This can be the case. So depending upon the class which is having the highest number of data point, okay, that class will going to be selected. Simple. And you can say, Govind, let's say you have 2 classes, class A and class B, and I have taken 6 point. 3 point got assigned to class A, 3 point got assigned to class B. In this case, both class have same number of point. So it's a tie. Okay. So randomly it can select any of the classes. Therefore, we should avoid using even numbers, because here k value is what? Even. So in case of even, there will be a chance of tie. So always prefer an odd number. Okay, guys?
Yes, thank you.
This is the case of classification, guys. How KNN will be used for regression. Listen this. Case of regression. In case of regression, it will take, see, in case of regression, you don't have any classes, because every data point will be different. You have continuous output data, salary of a person, house price. Every person will have different house price. Sorry, every person they have different salaries. Every price will have different prices. So you don't have any class. Okay, so unlimited classes you are there. So in case of regression, it will take the average of k points. For example, guys, in a class, okay, there are learners and a class a test has been conducted. Out of 100, everyone got the marks in the range of 80 to 85. Now, if you don't know the marks of other learners, how can you consider, okay, that learner that also must be getting like 82 marks, 83 marks? So you are taking the average of all other marks. Okay, that is the meaning here. Think like you have some data points. I'm not putting any class here. Why? Because every point will be similar, because you don't have any class. So you have now a new data point. This is a house price data set. Okay, you got a new house. We have to compute the price of it. So k value you have taken, let's say again 5. So it will pick 5 points. Okay, so these point they have picked. So P1, P2, P3, P4, P5. And now the value of new point, the price of this house is nothing but the average price of these 5 houses. This is your answer. Very simple. Clear, everyone? In case of regression, what will happen? It will take that many nearest point and they then compute the prices of these house by taking the average of them. So I'm giving you this quick note. Just give me 1 minute. You can quickly revise it. Just 1 minute. So guys, I have given one link in the chat box. Okay, please download these notes and please revise it. Just confirm, can you able to open the link? All of you.
Yes.
Okay. Start revising it. Then they will see their practical implementation.
So what do you want us to do? Download it and then do what?
Revise it.
What do you mean
Revise
by
it.
that, device?
Means have a revision of it. Read it.
Oh, okay.
Nikki, you have raised your hand. Any question you have?
Govind, can you explain that Euclidean distance formula again, where exactly it is used? I'm just trying to read and trying to understand between classification and regression, but then I also see the distance formula
See,
that you have explained.
this is basically using to compute the distance between two given points. Let's say you have a point A and point B in a 2D coordinate system. So this is the formula you will be using. Okay. to compute the distance between these 2 points, like from A point to point B. The distance would be take the x coordinate x2 minus x1 to the square plus y2 minus y1 to the whole square, and then take the under root of entire expression. And
Yeah,
this
but
formula is
where
used
do you
behind the
use this
scene.
in KNN?
See, I told you here, it will find the nearest data point. See, this is the new point. It will find the 5 nearest data point. How it can find the nearest? Anyhow, it will compute the distance, then only it can find, right?
Okay.
Okay, so for that purpose, it has been used behind the scene.
Got
Everybody
it.
have revised the notes? Please confirm all of you have revised.
Yes.
Okay,
Yes.
we can
Yes.
we can go for practical implementation. Okay, I'll explain you guys first about data set, what data set is all about. I don't have any CSV file with me for today's practical, so we will be using a data set from sklearn library. See, the dataset sklearn contains so many datasets. For example, iris flower, load digit, breast cancer, wine dataset, toy dataset. So one such I will be using very famous dataset called as iris flower dataset. Here we have 4 input column and 1 output column. It is the case of classification. It has 3 classes of flower. So I will show you the flower, iris flower dataset. See, this is the iris flower dataset here. Here you have 3 types of flower. The first type of flower name is setosa. Second, you have versicolor. And then you have virginica. 3 classes we have. Based upon which factor you are trying to classify the images, okay, of this flower. So notice one thing. This smaller leaf is called as petal. And this bigger leaf of this flower is called as sepal. Every flower will have different length of sepal and width of sepal, length of petal and width of petal. So depending upon the size of this sepal and petal, we will classify whether it is setosa, versicolor and virginica. So in the input column, you have 4 column actually. Sepal length, sepal width, petal length and petal width. And you have then output column. Output column will be having answers 0, 1, 2, 0, 1, 2, 0, 1, 2, like this. Because this setosa is called as 0. Versicolor is called as 1. It is called as 2. You know, machine learning cannot work upon text data. And these are output column. So we have assigned number 0 to the setosa, number 1 to the versicolor, and number 2 to the virginica. Okay. This is all about your data set. So in short, how many input column you have? 4 input column. And output column is just 1. And it has 3 classes. So it's not a binary classification. It's a multi-class classification data set. Clear everyone
Yeah.
about this data set? Okay. Guys, whenever you create your file, okay, you can give other name, let's say personal, like that you can give the name. The very first point is loading the required libraries. Import pandas as PD. Import matplot lib.pyplot as plt. Import seaborn as SNS. Warnings. Import warning library. Loading the dataset. So guys, how can you load? That's a very important question. Just write here one statement from sklearn, okay, dot datasets. So sklearn is a library. It is called a sublibrary. Import load iris. Okay, this is the statement you will be writing. So load iris is your dataset name. One more thing you have to understand, when you load dataset from sklearn library, guys, it will be in the dictionary format. Can someone explain me what is dictionary in Python? Quick.
Key and value.
pair.
List of
It's a
data,
key.
it has a key and value.
Key
You need
It's
value
a key. Yeah, it's a key and value pair, and the brackets are this curly bracket, right? Flower bracket. And key and value are going to be separated by colon. Now, I will just take everything in this iris variable. This is my main variable, which will be of dictionary type. Okay? Load iris. Now, if I print this iris, you will see. And from this iris dictionary, you will fetch input, output, column name, feature name, everything. See, I got this kind of result. Let me just minimize a bit. See, this kind of result I got. Don't write anything. I will provide you the notes. Okay. I will give the time just to write the code. Just listen as of now. I discussed here. In this, you have how many input column? 4 input column. See, 4 columns are given. Sepal length, sepal width, petal length, petal width. And this is stored in which variable? Data. See, it's a dictionary. See the curly bracket? Data is the key, and then colon, and this is the value of data. Yes or no? Key value pair, guys. See, colon, right? This is the key, and this is the value of that key. Means this is my input column, by the way. I'll fetch it. Now come down. Then see, you have a comma. Means here the first key and value pair is stopped. Second key is target, colon, and this is the value of that key. So if you have 150 input, definitely you will be having 150 output. I mentioned here Setosa is labeled as 0. So see, the first 50 values are Setosa. The first, then again, next 50 values are versicolor, that is 1. Then versica is labeled as 2. The next 50 is 2. And here you have given the target name, output name, what? Setosa, versicolor, and virginica. And come down, you also have something called as input column name. Input column name is called as what? Feature name. This is the key. What is the value? Sepal length, sepal width, petal length, petal width. And from where it is fetched on? iris.csv. Where it's stored? sklearn.datasets.data. Clear? Everyone
Yes.
about this dictionary? Perfect. It is a bit
Yes.
overwhelming to see in the one go, but if you just break into several components, you will understand. So our first point is to
Wait, I have one confusion again. Just can you please explain how this data set came, that petal and petal with petal length and sepal width and sepal length, all these points.
see. Yeah. So it has 4 columns, right?
Yeah.
And the sequence is given here. The first one is sepal length, then sepal width, petal length, and then petal width. This is how you can derive it. Okay.
No, I understood that, but I'm saying that means, means before classes we always loaded the data from the Excel file, okay?
Hmm.
But how come this data you load from the SQL?
Just because of these 2 statements.
Oh, okay.
Okay, so for that you should connect with the internet. So it will go to the sklearn website, and from that it will fetch this iris data. Okay. And
Oh,
when you
okay.
just do it in your collab file, it will be in dictionary format. And from this dictionary only, you will fetch your input column and output column and required stuff. I'll show you
Okay,
how.
understood.
Govind, is there a charge for sklearn?
No, nothing. Guys,
Means after these classes are over and all, and if you want to fetch the data from sklearn, we can still do that.
yes, it's free, open source library.
Okay, okay.
So guys,
Thank you.
input is called as capital X. So you will write iris dot data, because data is what? Input. Data key is what? Input. When you fetch like this, guys, you will see everything in the array format. And I don't like array format because it is not very good. You will not see the column names also. So what I will do, I'll convert this into a data frame. And then you will realize how better it would be. PD dot data frame. And I will also add the column names. From this iris data feature names. Because see, in the feature names, guys, you have what? All the column names. See, feature name is the key, and inside feature name only you have, see, all the column name. So when I write this, you will see it looks it in that case. Better, guys, now?
Much better.
Yes. This is how you can add the columns to each of the input data. And column is coming from this feature names. Let's take the output column also, guys. And these data sets are cleaned. You don't have to check for missing values, no duplicacy, no outlier. You don't have anything here. It's completely clean data. So chances are also high that your accuracy will be always 80 to 90% or even more than that. Why? And from PD dot data frame, iris dot target. And here you don't have any column name. I will give by myself as what? Target. See, this is your output column. So I have divided my input data and output data from this dictionary only. Once you have that, you can check the shape also. X dot shape. So basically, guys, you have 150 data points. Okay, you have total 150 rows. I will not check note. So here I can give the note as This is it. You will load from the sklearn. It will be clean. So no need to check for it. Now, once you have input and output data, guys, the first thing you will do. Okay, just tell me one thing. Have you heard about the feature scaling technique? Is standard scaler we learned yesterday, no, in the last class. Remember?
Yes.
Yes.
Do you think do we need to apply it here or not? You don't have so much difference in the data point. They are very similar. When one column have extremely higher values than the other one, then we apply just to compensate, right? But in this case, I think every data points are comparable. They don't have much difference, right? These values are very similar or not, guys?
Yes, very similar.
Yes.
So if you apply it or you don't apply, it doesn't make any sense. So I'm just not applying it here. Again, note, since all the data points have similar values, so no need to apply any feature scaling technique. Now we directly go for train, test, split. From sklearn dot give me the sentence. Give me
Model selection.
model selection, import train, test, split. And then x train, x test, y train, y test, train, test, split, x comma y, and then train size. Let's say I'm passing 0.75, means 75% data I will be giving for training, and rest 25% data will be given for testing. Let's say 42 I have passed. Tell me 75% of 150. Tell me the answer. 75% of 150. Quick.
113. 112 or 113.
Okay, so if I take the floor value, then 12, right?
Yes.
Very good. So guys, actually you have two things. Let's say, remember, go on mute all of you. You have, let's say, 112 point, what it was?
0.5.
0.5. It has two options, either to take ceil value. We have ceiling, right, in our home. And then you have floor value. So Python always consider the floor value. So it will be normalized at 112. Okay. This is called as floor value. So we have 120 record for training and 38 record for testing. Once we are done with this, then we load the model. I told you that here you can use it for regression as well as classifier. So first load the classifier from sklearn dot neighbors import k nearest
There's no U.
classifier.
There's no U.
And guys, you can also check it from this website. Wait, KNN classifier sklearn. And you see the documentation here. You will find all the quotations how to load the lab. See, from sklearn. Oops. From sklearn.neighbors import k neighbors classifier. Okay, you can directly copy it and paste. If you forgot the spelling or something like that, we can load. And then we create the model, creating the object, that is model. Model 1 k neighbors. And here, you can pass the value of k. See, you have the option of passing the k value. It says what? N neighbors. It has passed 3. I will pass as 5. N will pass at 5. So I have taken the k value as what? 5 here. Then what are the next step? Train the model.
Yes.
See, machine learning have fixed steps. Every time the algorithm will change, but the way you apply the algorithm will remain same for every model. So model 1 dot fit. This is like a story. X train dot Y train. So training data you have fit the model means your model has learned everything. It's time for making the prediction. So when you say model 1 dot predict, you predict on new input data and you store the result in which variable? Tell me.
Ypred.
Ypred.
Ypred. So Ypred is the output predicted by your model based upon new input data. And you also have the actual output. Actual output means the correct output, right? So correct output is Y test.
Yes.
So these are the answer given by your model. This one. And these are the answers which are actually correct for the X test input data. So let's compare them. If they are comparable, you will be having higher accuracy. If they are having lot of difference, then you will not get the proper accuracy. So performance matrix. Guys, in the last class, I explained about confusion matrix. Remember, all of you?
Yes.
Yes.
Import accuracy score and confusion matrix. One quick question. Here, the dimension of confusion matrix would be, what would be the dimension of confusion matrix here? Any idea? How many classes you have?
We have true positive, true negative, false negative,
No.
false positive.
We have how many classes? 3 classes. 0, 1, 2.
Three, yes.
So your output, the dimension of confusion matrix will be 3 by 3, right?
Yes.
See guys, here accuracy is 100%. Print confusion matrix Y test versus Y pred. So you don't have any other value. See, 15, 11, 12, and rest of the values are 0. 0 means they are misclassified values. So 0 is the misclassified values. Therefore, everything you are getting as in this diagonal. See, in this diagonal, you always have correctly classified values, correct? Now, it is giving me the accuracy as 100. So let's change this accuracy. What I'll do, I'll just tweak this algorithm. So here I will take the splitting as, let's say 80%. And I will make this random state as 0. So definitely different section of data will be divided. Correct? And random state I have taken 0. So the different set of data will be selected. Let's again run this code and let's see what is the accuracy of the model. It changed. How much? 96%. So depending upon the amount of data you are taking and what data you are taking for training the model, testing the model, your accuracy will be decided. So here I can say my model is 96% accurate. I hope guys this is clear to all of you.
Praveen, uh, probably I missed your what did you teach us before that? How did you select this 0.75 and random state 42? If you can please give me a reminder. Why
Okay, you
means
forgot this thing.
if you can please quickly remind
I
me.
spent around 1 hour in the previous class where I teach trend splitting. Anyways, so actually what happens when we take entire data, we have divided to two component, training data and testing data. We always keep the volume of training data higher than the testing data. Okay, so 0.8 means my entire data, which is having 150 record, 80% of that record will go for training. And what is this data? 20%, correct?
Yeah.
So 150 was the total number of values. So 80% of 150 is 120
Yeah.
and rest is 30, correct? Now,
Okay.
random state 0 I have taken. You can pass random state value from 0 to 100. You can take any value. It will just randomly pick the data from your training and testing. Let's say you have 150 record. So randomly it will pick 120 data point from the entire data. And rest of data will be testing one. So 0 will have a pattern of picking randomly. 1 will also have a pattern of picking randomly. So every value of random state has a fixed way of picking. So you can pass any value. Okay.
Okay. Okay.
So guys, I'm giving you this collab file link, all of you in the chat box. When you guys click on this collab file link, you can open it in your system and then you create a fresh collab file. Okay. Create a fresh collab file and whatever code I have written, write the same code over there guys and get your hands on done. Do it. Just confirm me, are you able to open the link or not?
Yes.
Yeah.
Yes, we can.
Good, work on it.
Govind?
Yes.
When we load data, so your data and my data can be different.
No, it will be same.
So, but when I did your step number 4 till Iris load Iris, then after that Iris, and I load the data, then it's different from you. Oh,
Again check.
okay, okay.
It will be same. Exactly same. Nothing will change.
Yeah, now same.
Yeah.
Okay.
So guys, I'm also giving a quick break. Okay. Meanwhile, you can complete all these steps. Has everyone completed? All of you?
No, Govind, I'm stuck on the name input. Input, and I think it is not. It's throwing me an error.
Okay, so show your
It says
screen. Show
sure.
the screen.
Share screen. Allow to share screen. You are able to see the screen.
No. You need to first accept the. Okay. Okay, you have
Yeah,
accepted the panelist
yeah,
request.
yeah. So here the name error is coming in.
You have not loaded the first part. Go to the beginning, first line. You copied that, you did not run. Why you did not run the first two lines?
Oh my, okay.
Second
Okay.
line also did not run. Ignore spelling is wrong. I should be under the quotation. Ignore.
Yeah, sorry. Yeah. Yeah, got it. Thank you. Thanks.
What about others, guys? It's completed or not?
Yeah, it's done.
Govind,
Will we?
yeah,
Yeah. Hello. Yeah. Tell me,
yeah.
Amna.
Govind, when I'm doing test size 0.75 and random state 42, then in my accuracy is showing me 96%. But when you did it, showing was 100%.
In my case also now it is showing me 96 because I changed the random state and train test size because data got changed, right?
But the
If
first
data
time
got changed,
it was 100%.
yes, in machine learning, even in see here data points are less. You have only 30 data points at the testing or 20. So if any one point gets misclassified, your accuracy will drop. Okay. So in machine learning, this is possible that first you got that one answer, now you're getting different. This is of course
I
possible. Okay.
didn't call anyone before. This is the first time I'm doing.
Yes. So now from this, make a consider every time you can't expect the same answer in machine learning. Okay.
Means either we repeat the same command even.
Yes. Yes. It'll be the same command. This is of course possible to get the accuracy as different. Not a problem. So guys, now we will do the second hands-on. This KNN regressor.
Govind, so one question. So even for the output, I have to run all over again, the same thing?
Yes.
Okay.
So guys, look at the screen. I have one hands-on here. See, KNN can be used for both classification and regressor. So now we are implementing KNN for regressor type of problem. Okay. So here I'm using this particular data set, that is house price data set. Download. Okay, so guys, this is your data set and this is my output column. And these are the input column. Okay, here I have continuous data, means the output is different for every single record. This is not a classification, this is a regression type of problem where your output will keep on changing. So I will use the same data to implement KNN regression. See, look at the screen, guys. The very first point is I have loaded the required libraries and then warning. Look at the screen. Here I loaded the data set. Okay, so first I will upload it here. Data is loaded. Then head function. Shape, if you want to check, there are total 506 number of rows you have. I'm checking here the missing values. So when I check that, so in the RM column, number of rooms per dwelling, RM columns is having 5 missing values. So what I will do, I will just delete these 5 rows. So if you have total 506 number of rows and if you delete 5 out of it, your answer will be 501 will be the overall answer. See, I am having 501 is the answer for rows. 501. Now, info function I'm checking. That will provide me some extra information about my given data set. Then same step, I'm splitting the data, right? I'm removing MEDV, the target column, okay? So that rest of the column I will get in the capital X. So see, till L stat, I'm giving in capital X. This is my input data. X stands for input data. And here I am taking Y as the output. In Y, I'm just taking last column as MEDV. Now it's standard scalar. Why? Because if you see the data points, every point have comparable values. See here 396, then you have 15.3, huge difference, then 296. So the column will have higher value, get the more preference. I don't want that to happen. For that, we will use standard scalar. These are the repeated steps that you know already. So first we create the object of a standard scalar, then apply fit underscore transform function on capital X, and then I'm converting my capital X into data frame. Otherwise, the look will not be good. Therefore, I convert it into data frame. And see, this is my transformed result. And you know, the standard scalar can only be applied on input data, not the output data, right? Therefore, I only use the capital X, not the Y. This is your new input data. And you know which formula gets applied behind the scene. So the formula is this one: new value, old value minus mean upon standard deviation. Remember guys this formula? All of you?
Yes. Yes. Yeah.
If you don't remember, means you need to watch the previous class recording. Here I am applying trend test splitting. Here I have given 80% data for training, rest 20% data will pass for testing. So 80% of 501 is 400. Okay, and rest is 101. Then model building. See, in the previous part, you were loading k neighbors classifier. But see, here you are using what? K neighbors regressor. Name will change. Okay, so don't use classifier for the case of regressor. It has two libraries separately for classification and regression. And I'm creating the model number 1. Okay, and then fit the model. And then we predict the output that you have predicted in this ypred variable. And what is the actual output? The correct data. This is the actual output. Y test, right? This is the actual output. This is my predicted output. And then come down. I'm computing the performance. In case of regression, if you want to compute the accuracy, you will be using what? R2 score. But in case of classification problem, you have accuracy and confusion matrix both. So see, I computed the R2 score. I got the accuracy as 84%. Okay, straightforward hands-on. So with this, we are able to complete both classification and regression problem with the help of this KNN machine learning algorithm. Clear, everyone? Regression one also.
Yes.
So I will not share this file to you. You apply KNN regressor by yourself. Okay, I'm sharing this collab file also, but I'll suggest you to don't copy the code directly. Okay, create a fresh collab file and try applying KNN regressor because you understood all these steps already. And I'm also giving the data set. So don't copy the code directly, just apply by yourself. And if you are stuck in somewhere, then only look at the answers. House price data. Okay, you have enough time, you can try this. Okay, don't copy the code, do it.
Hello, class is going on?
Yes, of course. I asked you to practice this KNN regression and waiting for you to complete that.
Oh,
Have you done, Varun? Completed for you? Okay, I'm sending the links again. This is the first link for collab file, and the second link is for house price data set. Completed, guys, and please don't copy the code. Okay, you will be writing by yourself, and let me know if you're facing any error. I'll fix it.
Govind, one question. Since I was not using Google Colab previously, I'm using it now, and I have not stored the housing price.csv file. I have stored it in my computer. So can I
I'll
pull
just
it
show
from my
you.
computer?
Okay. You can upload. Just show me your screen. I will guide you how you can load that.
Sure. Give me 1 second. Yeah. So this is my screen. This is where I had stored in my system. So, and that's where I'm
Okay.
trying to pull it in. So it's throwing me file not found. So probably it's looking inside the collab only, not outside the system. So
Okay.
I have stored it under this file, which is my. Where did it go, man? It's not moving out there. Can you see my folder?
Yeah. Yes.
Download
So do
folder?
one thing.
Yeah.
Yeah. Okay. Close this collab file. Again, create a fresh collab file.
Okay. Give me 1
Close
second.
this.
Yeah. Let me copy this
Okay.
item.
Now connect with the server.
Sorry? Connect. Okay.
Connect with the
Sorry.
server.
Okay.
Connect button.
Got it. Too many sessions.
Please close the previous sessions. All the previous sessions. Now click on manage session. Click on manage session once. And below, click on terminate other sessions. Below. At the last, you have.
Terminate other sessions. Okay.
Yes. Click and then close it. Now connect to the server once again. Okay. Now here load the libraries first.
Okay. Give me 1 second. Let me pull that in. Yeah. So now I have here dataset equals period.read.csv house price.cw.csv.
Now click on file option.
File. Okay.
No, not there. Give me the access your screen.
Yeah, go ahead. You can take the access.
Okay, access is not accessible here. Oh, no, anyways, left hand side you have multiple icons: search, X, the key button, and then file button.
Yeah, this one. Yeah.
Last one. Yeah,
Yeah,
last
this one.
one.
Okay. Mhm.
Now, don't click anywhere. At the
Mhm.
very top, you have arrow pointed upward, just below files. Yeah, click
This
on
one.
it. Yeah. Wherever you have that data set, select it.
Yeah. Diabetes. I can select multi select also, right? I can do the diabetes and everything together.
Why
So
you're doing diabetes one?
no, I just it's bigger. Oh, not for that file. Okay, got it. Okay. I thought
House
it was
price,
just pulling.
right?
House price.
I think number 12 you have, see? Come down,
Yeah,
feature
this one.
scaling
Yeah,
as this.
yeah, that's right.
Upload. Okay. Now, just hover your cursor, take the cursor on house price CWH file. Not there. Left side, see the file is uploaded. Now you
Yeah.
have three dot button.
Mm-hmm.
Click, copy path. And now paste that path over there under the quotation. Remove this, Control V. Now run it.
Got it. Okay. Great.
You
Thank
can
you.
close that
Yeah.
tab to the left side. Close it.
This one.
See, you have a cross button. Yes.
Yeah. Okay.
Yes. Apart from
Got
this,
it.
you don't have to click on any other option. Otherwise, multiple options will get open. That is why I asked you to again create a fresh collab file.
That's fine. Got yeah. So now logically, then if I am practicing for diabetes too, I can just go and upload the same way and
Do
open a
it.
new.
Below it, create one more option, dataset 2 equal to PD.CSV. Create new cell.
Where here? New cell. Okay. Got it. Okay.
Dataset 2.
Okay. Equals PD dot read. Yeah.
And go there in the file option where you have uploaded your data.
Same way.
Not there. Last option below.
This one, right? Yeah. Yeah.
Yeah. Then arrow.
This
Select
one.
the file. Yes, upload. Now copy
Yeah.
the path. Take the cursor to diabetes.csv file.
Got it. Okay.
Under the quotation, you have to paste the path.
Yeah. Yeah.
Also close the quotation.
Yeah. So it will not run here.
Now print
Data
dataset
set.
2 dot head.
Data set. Yeah, I didn't enter that. Yeah, sorry. Got
And
it.
you see,
Okay. Yeah.
it's
Thank you.
working, right?
Yeah. 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 Thanks. Yeah.
Good. Guys, anyone else who is getting the error, please confirm. Anyone who is getting the error, please confirm, guys.
In the output, no, I'm not able to get the answer.
Okay, the output part, you're having issues. Anyways, just share your screen. You just accept the panelist request.
Just a second.
Mm.
Okay.
I ask you to access, click approve. I will join as a panelist. Okay, so just convert that. Okay, I got it. Give the access. Remove that equal to. Okay. Equal to should not be there in that case.
Okay. Okay, sir. Thank you.
Anyone else, guys, having issues or wanted to ask something? Feel free. The first hands-on, which was for classification, is that completed for each one of you? The first one was.
Yeah, it's done.
Okay, and what about second one?
Yes.
You are still doing it?
Yeah, it's done.
Very good. So see, guys, in future machine learning algorithms also, the steps will remain same, though I will try to include few other steps also, okay, which you have not seen, so that I can increase the complexity of hands-on. But every time you will be having different machine learning algorithm, but these process will always be same: training, testing, prediction, performance matrices. Before that, feature scaling, dividing into input and output, checking the data, cleaning part, etc., etc. There we will not find any difference as such.
If you don't mind, do you have any idea, or can you give us like a brief information on how many topics we have more and all?
Okay, so you have multiple other algorithms, for example, decision tree, machine learning algorithm, then you have random forest, and then we go for unsupervised learning. In unsupervised, you have in random forest, and then you have Ada-Bush algorithm, KNN. Okay, K means machine learning algorithm, then hierarchical
Mm-hmm.
clustering,
Mm-hmm.
afterward
So,
association rule mining,
mm-hmm.
then principal component analysis. That is the topic of machine learning, and then
Mm-hmm.
we start deep learning class.
So roughly, like it's like one more month to complete
Yeah,
our syllabus.
one more month in total, minimum.
Yeah, yeah, of course, 1 month. So February mid or something. End. Okay. And then
In
we
the
have
very
that.
beginning, in the very beginning, I'm not going a bit fast, but yes, from next week itself, I will just increase the pace because it was the start of machine learning. Now you guys are feeling comfortable, I believe, right? With these topics.
So after we have after all this is completed, we have that project or that AWS certification classes.
That will go parallelly. Okay, so you team will inform you regarding that, but project part we will be completing in deep learning. Okay.
Is it AWS certificate or Microsoft?
No, it Azure.
Azure. Sorry,
Yeah.
Azure.
Yeah. And then go
Okay,
ahead.
for
What's
that you will be having an exam also that you will be clearing first. Okay.
I'm sorry.
Then only
What's the next topic for tomorrow?
tomorrow we will be learning about decision tree, machine learning algorithm, and random forest.
Thank you.
Okay, guys. So please complete these hands-on. Okay, and if you get time, revise also. Tomorrow we will be connecting and learning the random forest, decision tree, and ensemble learning processes. Okay.
Just last question.
Okay, thank
For
you.
all the things we learned, do we have any practice questions or somewhere I can find online? Do you have
Tomorrow I
any?
will be giving some set of questions. Okay, which we will be
Okay.
practicing in the weekdays.
Okay. Thank you.
Okay, thank you.
Okay, guys.
Thank
Bye bye.
you. Bye.
Thank you. Bye.
Thank you. Bye bye. See you tomorrow.
You.